Hello viewers, with us here on the board we have a question under dimension analysis. We're saying that the law of radioactive decay is n of t which is equals to n naught and multiplying with some exponential function which is raised to the power negative lambda multiplied by t. Now here, this equation that we have that a naught is the number of some radioactive nuclei, and lambda is simply the decay constant, and still this is a time. So now our question is telling us to find the dimensions of lambda. Okay, now what we know about dimensional analysis is that when you have trig constants, you can also talk of exponential functions and even constants. Let's talk of numbers, pi, and all that. They are regarded to have no dimensions, or in short, they are dimensionless. So what we're going to do is, looking at this one, since this lambda is simply a decay constant, and a constant has no dimensions, so it will therefore imply that lambda multiplied by t is simply equal to a constant which has no dimension. So we say lambda multiplied by t is simply equal to 1, because when you talk of the dimensions of 1 is simply equal to, it does not dimensions in short. Now here our main aim is finding the dimensions of lambda. So what we're going to do is, since the product of lambda and t is equals to 1, finding lambda, we're going to divide by t, divide by t. So meaning that we have that lambda is equal to 1 over t. Now this means that lambda is simply inversely proportional to what? To t, which can also be written as lambda being inversely proportional to t. Now the reason why we are not choosing the inverse proportionality is because we are going, when we substitute this with an equal sign or a constant, of which the same constant we still have no dimensions. So this therefore means that this is not necessary. Now we have lambda equal to 1 over t. But what you know is that t is the term we're talking about here, and time has dimensions of a capital letter T. So since we know the dimensions of t, we can then conclude to say that lambda is simply equal to, this one can also be written as t to the power negative 1, which means that the dimensions for lambda are simply equal to the inverse of time, which is t to the power negative 1. So with this we have found our dimensions for lambda.